Okay, hello. So we're now on integration by trigonometric substitution. So this is another substitution approach in finding the integral of a given function. Uh, Integration by trigonometric substitution so uses or suggests a certain substitution. So depending on the format of the given integrand. So it resembles that of the format for inverse trigo. Okay, so for example, if we can see a given integrand, so which involves the square root of a squared minus x squared, wherein a here is constant. Okay, so a here is constant, uh, and then minus x squared. Okay, so remember in inverse sign, that is 1 minus u squared. So the parameter that we're going to substitute then will be x is equals to a sine theta. Okay, so x is equals to a sine theta. And then afterwards, so we need to derive x, so derivative of sine theta, so it's just cosine theta, d theta. So multiply it with the constant a. So if it involves sum of a squared and x squared, so that is tangent. Okay, so regardless of whether that has a radical sign, okay, or it involves radicals or not, okay, so as long as it is sum of a squared and x squared, so then we can substitute x to be equal to a tangent theta. Then the derivative of tangent is secant squared theta d theta. If it is a difference between x squared minus a squared, okay, so that is secant. So we are going to substitute x to be equal to a secant theta. So its derivative then so would be derivative of secant, which is secant theta tangent theta d theta. So multiply it with the constant a. Okay, so those are the suggested substitution, okay, so that we will be using. So if a given integrand, okay, so involves a difference of two squares, okay, or a sum of two squares. So to better illustrate that one, so let's have our first example. So the first example would be the integral of the square root of 1 minus x squared dx. So the square root of 1 minus x squared dx. And among the three, okay, so among the three, so it resembles the first one. Okay, so because a here would serve as, or a squared will serve as 1, and then our x, of course, is the same as the x squared. So therefore, the one that we will be substituting there, so will be a sine theta. Okay, so our a squared, okay, so our a squared here is 1, then our x squared is the same as the x squared. So therefore, the one that we will be substituting there is we're going to let, okay, so we're going to let x to be equal to a sine theta. So a sine theta. But then our a, it's 1. Okay, so a is 1, so therefore that would just be sine theta. So we're going to let x to be sine theta, and then we're going to derive that one, so dx to be equivalent to cosine theta d theta. And afterwards, so we're just going to substitute. Okay, so the integral then so would be 1 minus our x there is sine theta. Okay, so x is sine theta, and then square it, so that is the same as sine squared theta. And then multiply it with dx. So our dx is cosine theta d theta. Cosine theta d theta. So from here, we have our identity. So remember the Pythagorean identity that we have the cosine squared theta, so plus sine squared theta is equals to 1. So therefore, 1 minus sine squared theta is equivalent to, okay, so cosine squared theta is equivalent to 1 minus sine squared theta. And we substitute that. So that would be the square root of 1 minus sine squared theta is cosine squared theta. And multiply it with cosine theta d theta. And then the square root of cosine squared theta is cosine theta. Multiply it with cosine theta d theta. So finally, so we can combine this one as cosine theta times cosine theta, so which is cosine squared theta d theta. So from here, we can now integrate this one. Okay, so the integral for trigo-substitution is we're going to use the principle that we have learned so from trigo transformation. But in this case, it's just a simple usage of an identity for cosine squared. But since cosine is or it has an odd or an even exponent, so we just use the identity. Okay, so the identity that we will be using would be for cosine. Okay, so cosine squared theta is 1 plus 1 plus cosine 2 theta all over 2. Okay. So therefore, this one is 1 plus cosine 2 theta all over 2 d theta. So we separate the two. So this is the same as 1/2 the integral of d theta, then plus 1/2 the integral of cosine 2 theta d theta. So the integral of this then so will be 1/2 theta, then plus 1/2. But remember, so the integral of cosine 2 theta, it's positive sine 2 theta. However, we have 2 theta there. Okay, so we neutralize the 2d theta, so by multiplying it by 1/2 plus c. So finally, so we have this one as 1/2 theta plus 1/4 sine 2 theta plus c. And this is the answer. Okay. So after using some trigo transformation. However, this is not the original integrand. Okay, so we have to transform it back to the original given, so which involves x. Okay, so to do that, so remember that we use the so we let x, okay, so to be equivalent to sine theta. So remember that sine theta is equivalent to opposite over hypotenuse, right? So sine theta is opposite over hypotenuse. So in this case, so x over, it's the same as x over 1. So making this one sine theta to be equivalent, the opposite side will be x, and then the hypotenuse side will be 1. So I'm going to draw a right triangle. So given that this is theta, so this one will serve as the opposite side, so which is equal to x, and then this one will serve as the hypotenuse side, which is equivalent to 1. So how do we get the remaining? Okay. So the remaining here, so we could use the Pythagorean identity, so that the hypotenuse, square of the hypotenuse, okay, or the square of the two sides. So in this case, that will be this is the adjacent side, right? So the adjacent side, square it. So plus the opposite side, square it, is equals to the hypotenuse side, square it. So adjacent side, so the opposite is x, then square it. So 1 square. So therefore, the adjacent will be 1 minus x squared. And then we take the square root of both sides. So the adjacent is just 1 minus x squared. Actually, if you follow the process, the remaining side, okay, so will always be the given. So which is this one. So that's why we substituted x goes to sine theta. Every time that we're doing that one, so the remaining side, so will always be the given. So 1 minus x squared. So this is 1 minus x squared. Okay, so now that we have this triangle, so we just need to transform. Okay, so what is theta? So for theta, So we can use our given. Okay? So remember that x is equals to sine theta. Okay? Right? So x equals to sine theta. So therefore, arc sine theta, it's the same, or sorry, arc sine of x, arc sine of x is the same as the theta. Right? So to get the value of theta, so we take the arc sine of x, that will be equal to theta. However, we have the sine 2 theta. Okay? So sabi natin dito, we have half or 1/2 of theta, so plus 1/4 of sine 2 theta. So sine 2 theta, what we only have here is theta. So but what we have is 2 theta. So to find the equivalent algebraic function for that, so we need to use identity. So the identity for sine 2 theta, so that is 1/4. So remember this one, the sine 2 theta, it's the same as 2 sine theta cosine theta. So that's the identity. So therefore, that's the one that we will be substituting here. So 2 sine theta cosine theta. So which is, so 1/2 theta, so plus 2/4 is 1/2. So sine theta cosine theta. So sine theta or theta is arc sine theta. Okay, so this one. So that is 1/2 arc sine of x. But then we have 1/2. How about for sine theta? So sine theta can be taken so using the triangle. So sine theta is opposite over hypotenuse. Actually, it's already in the given that sine theta is x. Okay, so sine theta is x. Then cosine theta is adjacent over hypotenuse. Okay. So okay. Adjacent. So adjacent is square root of 1 minus x squared. Then hypotenuse it's 1. In short, our final answer then, so the integral will be 1/2 arc sine of x plus 1/2 x times the square root of 1 minus x squared plus c. Okay, so that's how we get the integral. Okay, so using trigo substitution. So the process is a bit longer. However, you just need to be familiarized with it. Then you'll get used to it afterwards. Okay. So the first thing to do there is to determine, okay, so what are we going to substitute? And then once you're able to determine that, so you substitute, and then so you simplify. So once you simplified it, so most of the time it will be trigo transformation or direct application of integral for trigo functions. And then once you got the answer, okay, so you have to transform it back to the original algebraic function. So to do that, so we go back to our assumption, and then we draw the right triangle. And then from there, so using the right triangle, so we will be able to transform the answer. Okay, so going back to the algebraic function. Okay, so that is our first example. So for a second example, so we have x squared minus 1 raised to 3 all over 2, and then divide it with x. Okay, so divide it with x. So it starts with x squared minus 1. Okay, so x squared minus 1, so that means it resembles the format for secant. Okay, so if it is minus, it's either sine or secant. Okay, so if the constant is positive, okay, so that makes it sine. Okay, so if the constant is negative, that makes it secant. So we're going to let them Okay. So we let okay, so our a here, so a is 1, okay, or a squared is 1, and then our x squared, it's x squared. So therefore, so we let x to be equal to a secant theta. So x, then our a is 1, so it would just be a secant theta. So once we derive it, so that would be secant theta tangent theta d theta. Secant theta tangent theta d theta. And then we substitute. So x squared, so x is secant, so therefore x squared then so will be secant squared theta, then minus 1, then raise it to 3 all over 2 all over our x is secant theta. Our dx is this, so which is secant theta tangent theta d theta. So x squared is secant theta and then square it, then minus 1 raised to 3 over 2. So x at the denominator is secant x or secant theta. Then our dx is secant theta tangent theta d theta. Okay. So now that we have that, so we are going to use the identity. So there's an identity for secant squared minus 1. So remember that we have 1 plus tangent squared theta is equals to secant squared theta. So therefore, tangent squared theta is equals to secant squared theta minus 1. So we can make that one as the integral of, so tangent squared theta, so raise it to 3 all over 2, and divide it with, we can cancel out secant already, so secant theta and secant theta. I don't need to divide that one, so multiply it with tangent theta d theta. However, we have tangent squared, and then raise it to 3 over 2. So 2 and 2 would cancel out. So that would just be tangent raised to 3 theta, and multiply it with tangent theta d theta. And as we transform this one as tangent to the 4th theta d theta. So tangent to the 4th theta d theta. So this one is case 4. Okay, so it involves a single tangent. So therefore, so we transform this one. So using trigo transformation as product of two tangent. Okay, so tangent squared and tangent squared theta d theta. And then we use the identity. Okay, so for tangent squared. Okay, so for tangent squared, so similar with this identity. Okay, so this one. So that is tangent squared theta. So that is secant squared theta minus 1 d theta. And then we distribute. So tangent squared theta, then secant squared theta, then minus tangent squared theta. Everything is multiplied with d theta. Okay. So this one can be integrated already. So since the integral of tangent is secant squared, so we can use power rule there. However, the tangent squared theta d theta so cannot be integrated right away. So we need to use another identity. And we're going to use the same identity. So the good thing here is transformations so will only lead to sine, cosine, tangent, and secant. Okay, so there's no transformation involving cosecant and cotangent. Okay. So for tangent squared theta, so we have the secant squared theta minus 1, then d theta. And then secant squared has an integral already. So tangent squared theta, then secant squared theta d theta. This is minus secant squared theta d theta. So negative and negative 1, so positive the integral of d theta. So finally, so I can now integrate this one. Okay, so we're in for the first one. So our u here is tangent theta. So our du then will be secant squared theta d theta. So this one can be integrated right away using the integral of secant squared, and then d theta can be integrated as well. So therefore, this is tangent cube theta all over 3. And then this is minus, so secant squared is tangent theta, and then plus theta, okay, plus c. So that would be the integral. So the next thing is we just need to transform it back to the original equation or to the original integrand. So we let x then, parang ang x natin is secant theta, no? So therefore, our secant theta, so secant is inverse of cosine. So hypotenuse over adjacent side. So secant is hypotenuse over adjacent side. So the hypotenuse there, so sorry. And this one will serve as ito. So para siyang x over 1. So x all over 1. So drawing the triangle, so that will be our theta. So hypotenuse is 1. Adjacent side is x. Okay. So therefore, that would be 1 squared minus x squared, and then this is square root 1 minus x squared. So similar with the original. Sorry, baliktad. So it's not the same. So hypotenuse is x, and then our adjacent side is 1. So therefore, this will be x squared minus 1. So similar for this one. So x squared minus 1. So now, so how do we write our final answer? So we need to find what is tangent theta. So tangent theta is opposite over adjacent. So opposite, okay, so this is opposite adjacent hypotenuse. So tangent is opposite over adjacent, so that would just be x squared minus 1 raised to 1/2. Okay, so that is our tangent theta. And then it is raised to 3 divided with 3. And minus tangent theta, so that's it. So that we have x squared minus 1 raised to 1/2. And then plus theta. So theta can be taken here. So theta would be arc secant of x. Arc secant of x. And plus c. So we can have this one as x squared minus 1 raised to 3 all over 2 all over 3. And minus x squared minus 1 raised to 1/2 plus arc secant of x plus c. But if we want to make it in radical form, so that will be okay as well. Okay. If we want in radical form, so this would be the square root of x squared minus 1 raised to 3 all over 3 minus the square root of x squared minus 1 and plus arc secant of x plus c. So either of the two will be our answer. Okay. So this one involves secant. Okay. So number 3, this time, so it's sum of x squared and 1. So 1 will be our a squared, x squared is x squared. So therefore, we're going to let x to be equivalent to a tangent theta. Then since a squared is 1, so a is still 1, square root of 1 is 1. So x will be tangent theta. So dx then so will be secant squared theta d theta. So we substitute. So x squared. So x is tangent theta. So therefore this would be tangent squared theta plus 1 all over our x is tangent theta. So dx is secant squared theta d theta. But then 1 plus tangent squared theta, that is the same as secant squared theta. So we substitute that one. So this is secant squared theta all over tangent theta times secant squared theta d theta. So this will become secant squared, so the square root of it will be secant theta, okay, so all over tangent theta, and multiply it with secant squared theta d theta. So what can we do? Okay, so with this one, so we can use some identity. Okay, so for us to answer this one, because we cannot just simply use trigo transformation here because the tangent is at the denominator. Okay. So what we can do here is transform this one into a sine and cosine. Okay. So for the second, okay. So remember that, so cotangent theta is the same as 1 over tangent theta. I'll transform it. So taas natin siya. So it will become secant theta. And then I'll have multiplied with cotangent theta. And then we have the secant squared theta d theta. And then afterwards, we can do this one as secant is the inverse of cosine. So 1 over cosine theta. Right? So secant is 1 over cosine theta. And then cotangent is cosine theta over sine theta. And multiply it with secant squared theta d theta. And then afterwards, so we can make this one as, or cancel that out. So I'll have the 1 over sine theta, 1 over sine theta, then multiply it with secant squared theta. So the other thing to do then, so we can transform the secant squared. Okay, so I make that one. So secant is 1 over cosine. No? Or transform that to tangent muna. No? So secant squared, that is the same as tangent squared theta plus 1, and divide it with sine theta d theta. Tangent squared theta, okay, plus 1 over sine theta. Then afterwards, so I can make or this one as the integral of 1 over sine theta, then multiply it with, so tangent squared, so that is the same as sine squared theta over cosine squared theta plus 1, and multiply it with d theta. And afterwards, so this one, so once I distribute the 1 over sine theta, so that will become sine theta all over cosine squared theta, right? So sine theta plus, okay, and then plus 1 over sine theta d theta. Okay, so I can now integrate this one. So how do we integrate these? So we can make the first one a simple power rule. Okay, so I'm going to transform the cosine squared or transfer it to the numerator. So that is the same as cosine. Okay, so cosine theta, and then raise it to -2, then multiply it with sine theta d theta. Then the other one, so 1 over sine theta, that is cosecant theta d theta. Okay. So in here, so our u will become cosine theta. So our du will be negative sine theta d theta. Our neutralizing factor then will be a -1. So that's our answer there then. So will be, so neutralizing factor of -1, then multiply it with cosine theta, -2 plus 1, that would be -1. Cosine theta, then -1 all over -1. So -1, multiply it with cosine theta raised to -1 over -1. So power rule. And then we have the integral of the cosecant, right? So the integral of cosecant will be plus ln of cosecant theta plus, or sorry, cosecant theta minus cotangent theta. Plus C. Or negative and negative, so that would be positive. And then 1 over cosine theta. So 1 over cosine theta, then plus ln of cosecant theta minus cotangent theta plus C. But then 1 over cosine theta is secant theta. So the answer would be secant theta plus ln of cosecant theta minus cotangent theta plus C. Then we go back with our original. So what do we call that one? The x is equals to tangent theta. So x is equals to tangent theta. And then tangent theta is opposite over adjacent. So opposite is x, adjacent is 1. So we write the triangle. So opposite is x, adjacent is 1. So therefore, this one will be x squared plus 1. Similar to this, x squared plus 1. So we just need to find, so what is secant? So secant is Second is cosine. No? So hypotenuse over adjacent. Hypotenuse. Okay, so this is hypotenuse, adjacent, opposite. So second is hypotenuse, square root of x squared plus 1. Adjacent is 1. Okay, so it's just square root of x squared plus 1. And plus ln of cosecant. So cosecant is hypotenuse over opposite. Square root of x squared plus 1 all over x. And then cotangent. So cotangent is adjacent over hypotenuse. So 1 all over x plus c. So that will be our final answer then. Square root of x squared plus 1, and then plus ln of the square root of x squared plus 1 all over x minus 1 all over x plus c. Okay. So this is not transformation, okay? But more on the usage of some identities, okay? So until it will become integrable. Okay, so let's have number 4. Okay, so this time, so for example, number 4, so it's not just a simple x and 1. Okay, so in here, so we can see that our a squared here is actually 4, so therefore our a here will be 2. And then our x squared there, okay, so is 9x squared. So I'm not going to use x equals to 9x squared. It's just 9x squared. So therefore our x then will be 3x. And that is the one that we will be substituting. Okay, so we'll have 9x squared, and then we'll have the square root of it, which is 3x. So supposedly, so what is suggested here will be, so since it's minus, the constant 4 is positive, so it should be, supposedly it should be x is equals to a sine theta. However, in here, this one will serve as our, okay, so this one will serve as our x, and this one will serve as our a, which is 2. So therefore, our x then will be, it's 3x. Okay? It's not just simple x. It will be 3x, and then our a, it's 2 sine theta. Okay, so 3x is equals to 2 sine theta. So its derivative then, so will be 3dx. So derivative of sine will be 2 cosine theta d theta. And that's the one that we will be substituting after. Okay. So we'll be substituting for x cubed. Okay. So what will be our x then? Okay, so in here, so we can see that x is 2/3. Okay, so x is 2/3 sine theta. X is 2/3 sine theta. Then our dx, it's 2/3 cosine theta d theta. And therefore, so x is 2/3. Okay, so 2/3 sine theta, and raise it to 3. Square root of 4 minus 9, with our x is 2/3 sine theta, then square it. Then our dx is 2/3 cosine theta d theta. So this one will become then, so 2/3, so 8. So 3, 9, 27, then sine cube theta. So this one will become 4 minus 9 times So 4 over 9 sine squared theta. And multiply it with 2/3 of cosine theta d theta. So I'll multiply the constant. So 8 times 2 is 16. 27 times 3. 7 times 3. 6. 81. 16 over 81. Then I'll have the I'll have sine cube theta, then cosine theta, and multiply it with, so this one would cancel out. And then I'll have 4 minus 4 sine squared theta. I can factor out 4 there. So it will become 1 minus sine squared theta, then d theta. And afterwards, so I'll have the square root of 4. Okay, so square root of 4 is 2. So multiply it with 16. So that will become 16 times 2 will be 32 all over 81. Then sine cube theta, cosine theta. So 1 minus sine theta then will be cosine squared theta, d theta. And finally, so we'll have 32 all over 81 and sine cube theta. So the square root of cosine squared theta is cosine theta. Multiply it with another cosine theta. So we'll have cosine squared theta d theta. And then, so this one, so we have a product of sine and cosine, and then one is add. Okay, so therefore, so we transform that one as sine squared theta, so times sine theta, cosine squared theta d theta. So this one will just be power rule. So I need to transform sine squared to cosine. So 1 minus cosine squared theta. And then I'm going to interchange this one. So cosine squared theta times sine theta d theta. So sine squared theta is 1 minus cosine squared theta. And then I'll proceed with cosine squared followed by sine theta d theta. So this is this one, and this is this one, and then this is this one. And finally, so we distribute. So we distribute cosine squared. So we'll have cosine squared theta, so minus cosine to the 4th theta, then sine theta d theta. Finally, so this one will be 32 over 81, the integral of cosine squared theta, sine theta d theta, and minus 32 over 81, the integral of cosine to the 4th theta and sine theta d theta. Then our u here would be cosine theta, so its du will be negative sine theta d theta. So its neutralizing factor then will be negative 1. So this will become negative 32 all over 81, and then power rule, so cosine cube over 3. Then the negative neutralizing factor of negative 1, so it will become positive 32 all over 81. Then I'll have cosine to the 5th theta all over 5 and plus c. So we can make that one as negative 32 all over 243. Okay, so negative 32 over 243 cosine cube theta, then plus 32 all over, so 405 cosine to the 5th theta plus c. So we just need to transform it back. So when we transform it, we go back with our original that 3x is equals to 2 sine theta. So 3x is equals to 2 sine theta. So therefore, it's the same as, so divide both sides by 2. So it would appear that sine theta, which is opposite over hypotenuse, is the same as 3x all over 2. So if we write the triangle there, so this is theta, our opposite, adjacent, hypotenuse. So our opposite is 3x. Our hypotenuse is 2. So therefore, our adjacent side then will be 4. Okay, so 2 square is 4, and minus 9x squared. So which is the original? Okay, this one. So finally, our answer then will be negative 32 all over 243 cosine theta. So cosine is adjacent over hypotenuse. Negative 32 over 243. Cosine will be four minus 9x squared raised to 1/2, and then raise it to 3. Okay. So negative 32 over 243. Cosine theta is 4 minus 9x squared. Okay, so raised to 1/2. Sorry, it should be all over 2. But then this should be only at the numerator. Because cosine theta is 4 minus 9x squared. Sorry, it's kasama yun sa baba. So it's square root of 4 minus 9x squared, and then divide it with 2, and then raise it to 3. And the other one is plus 32 over 405, then multiply it with 4 minus 9x squared, so raised to 1/2 all over 2, then raise it to 5. So finally, so what we have there would be, so 2 raised to 3, the one denominator. So 2 raised to 3 is 8. So negative 32 all over 8 is negative 4. So negative 4 over 243. And then that will be multiplied with 4 minus 9x squared. So 1/2 times 3 is 3 over 2. And then plus, so 2 raised to 5. So 2, 4, 8, 16, 32. So 2 raised to 5 is 32. 32 over 32 will just be 1 all over 405. And then 4 minus 9x squared raised to 5 over 2 plus c. And that's the fourth example. So the solution are a bit long. Right? Okay, so let's have another one. So example number 5. So we have x squared minus 9. So in here, so we still have x squared. And then for our a squared, which is 9, so therefore a, it's 3. So we just let then x to be equivalent to a secant theta. But then our a is 3, so x goes to 3 secant theta. So dx then will be 3 Derivative of secant theta is secant theta tangent theta d theta. So we substitute. So x squared will be 9 secant squared theta minus 9 over our x squared will be, so x is, so 9 secant squared theta. And we multiply it with dx, which is 3 secant theta tangent theta d theta. Then, so we can factor out 9. And then the square root of 9, that is 3. So secant squared minus 1 is tangent squared. Square root of tangent squared, it's tangent. It's the same as 3 tangent theta. Over 9 secant squared theta, multiply it with 3 secant theta tangent theta d theta. So what's happened then? So 3 times 3, it's 9, divided with 9, which is 1. And then, so secant, so we still have 1 there, so, but this one will be cancelled out. So I'll have then, so tangent and tangent, so will be tangent squared theta, and the one below will be secant theta d theta. So secant theta d theta. So what are we going to do then? Okay. So this is not a direct transformation approach. It's because it's not a product of tangent and secant, but it's a division of tangent and secant. So what we'll be doing then, so we'll be use the identity. Okay, so for tangent squared, so which is secant squared theta minus 1, okay, so over secant theta d theta. Then secant squared over secant squared, that is just secant theta, then minus 1 over secant theta d theta. So which is just the same as secant theta d theta minus secant is cosine theta d theta. So we can now integrate this one. So the integral of secant is ln of secant theta plus tangent theta. And integral of cosine, it's negative sine theta plus c. So we transform it back. So we have x equals to 3 secant theta. So secant theta is the same as hypotenuse over adjacent side. So that is x and this is 3. So we write the triangle. So hypotenuse is x, adjacent is 3. So therefore this is x squared minus 9. So finally, so ln then our secant theta is x over 3. Tangent is opposite. So square root of x squared minus 9 all over 3 minus sine theta. So square root of x squared minus 9 all over x plus c. So this is a direct one. Sample number 5. Okay. So for example number 6, okay, so we have x over the square root of x squared plus 4x plus 5. So in this case, let's not or it does not follow the format that we have. Okay, so for trigo substitution, however, we need to transform first the integrand into the format of trigo sub. So what are we going to do? So we perform uh, completing the square. Okay, so to make this one as a sum or difference of squares. So to do that one, so we get half of the middle term. So middle term is 4, and then square it. So half of 4 is 2, square it is 4. So therefore, that's what we will be adding. So we add, or we add and subtract 4. That would be x over the square root of, so x squared plus 4x. Then we add 4, we minus 4. Then, of course, we have the plus 5. Ito lang ginawa natin. The plus 4 minus 4. Kasi 4 minus 4 is still 0. So we haven't done anything on our integrand. Kasi what we want is, ayun nga, no? This one will become square root of, so x squared plus 4x plus 4. And then we group these two. So negative 4 plus 5. So minus 4 plus 5, that will be plus 1. And then this one is a perfect square. So which make this one as x over the square root of x plus 2 square plus 1. So x plus 2 square plus 1. Okay, so from there, so our x, okay, so will serve as the x plus 2. And then our a, it's still 1. So remember that the one that we will let here, so since this is sum, so we let x to be equivalent to a tangent theta. But then our x here, so would be the x plus 2. And then our a, it's 1, tangent theta. Just simply x plus 2 is equals to tangent theta. So we derive this one, derivative of x plus 2, it's dx. So tangent is secant squared theta d theta. And afterwards, so we substitute. So in here, so what is our x? So x is the same as tangent theta minus 2. So we transpose the plus 2 there. So tangent theta minus 2. So x then will be tangent theta minus 2 all over 1 below. Okay, so x plus 2. This one is x plus 2, which is tangent. And then square it. So tangent squared theta plus 1. So dx is secant squared theta d theta. So this would be tangent theta minus 2 all over. So tangent squared theta plus 1 is secant squared. Then square root, that will just be secant theta. Times secant squared theta d theta. So this one would cancel out. So what retains there would just be a secant theta. So pag distribute natin yan, so that would be secant theta, or okay, this is tangent theta minus 2 times secant theta d theta. So next, so that would be product, so distribute, so secant theta tangent theta d theta minus 2 integral of secant theta d theta. So minus 2 secant theta. So we can now integrate this. So the integral of secant theta d tangent theta, it's simply secant theta. And minus 2, integral of secant theta, it's ln of secant theta plus tangent theta plus c. But then what we have there is x plus 2 is equals to tangent theta. X plus 2 is equals to tangent theta. Or in short, so tangent theta, so which is opposite over adjacent side. Opposite is x plus 2, and this one is over 1. All over 1. So for our triangle, so opposite is x plus 2, adjacent is 1. So therefore, this is x plus 2 squared plus 1. X plus 2 squared plus 1. So which is the same as kanina, x squared plus 4x plus 5. So our second is hypotenuse over adjacent. So which is just the square root of x squared plus 4x plus 5 over 1. Then minus 2 ln of square root of x squared plus 4x plus 5. Then our tangent is x plus 2 all over 1 plus c. X squared plus 4x plus 5 minus 2 ln of 1, or ln of the square root of x squared plus 4x plus 5 plus x plus 2. So that is how we get that one. That's correct. So let me have the final example. Or so I have two more. Okay, so there are a lot of examples. Let's say we have the square root of x times the square root of 10x minus x squared dx. So how do we answer this one? Again, it does not have, or it does not resemble any, okay, of the parameters that we can substitute, and because there's an x and an x squared under the radical symbol. What we can do with this one is we can apply again the we can apply again so I can rewrite this one as x and then multiply it with, I want to make the x squared positive, so I can use the completing the square. So I'll factor out negative, it will become x squared, and this would become minus 10x. So x squared minus 10x, and then I'll take half of the negative 10, then square it. So in short, I'm still going to add, so 10 over 2, it's 5 squared, so we'll have 25. So that is what we will be adding there then. It will be negative, so x squared minus 10x plus 25 and minus 25. Of course, we have the x there. And afterwards, so x, the square root of I'll start with this 3. Okay. So this 3 is the same as x minus 5 squared. So x minus 5 squared. So that is x squared minus 10x plus 25. Then I have a negative and a negative 25. So I'll make it plus 25 then. So in short, so this is the same as, I'll make it 25 minus x minus 5 squared dx. So it's 25 minus x minus 5 squared dx. So from there, so we can say that our a, okay, so a squared is 25. So a is 5. And then from here, our x would be x minus 5. So we let, so this one x should be a sine theta, right? Then our x is x minus 5, and then our a is 5, and sine theta. So x minus 5 is equals to 5 sine theta. So dx then will be 5 cosine theta d theta. So we substitute integral of our x. So this one for our x, so x is equal to 5 plus 5 sine theta. Okay, so we transpose to negative 5. So x is 5 plus 5 sine theta. And then we have the square root of, so 25 minus our x minus 5, it's 5 sine theta. Then square it, so it's 25 sine squared theta. Then multiply it with dx. Our dx is 5 cosine theta d theta. And finally, so we'll have, 5 times 5, or 5 plus 5 sine theta. And then the 25, so I can factor out 25, so it's square root of it, it's 5. And then 1 minus sine squared, it's cosine squared, square root of it is cosine. So therefore, that's the same as 5 cosine theta, then 5 cosine theta d theta. So we have then 5 plus 5 sine theta. So this one will be 25 cosine squared theta d theta. And finally, so 5 times 25, so we'll have 125 cosine squared theta and plus 125 cosine squared theta sine theta d theta. So, okay, so 5 times 25 is 125. So I have cosine squared, and the other one cosine and sine. Okay. So we distribute. So we'll have 125 integral of cosine squared theta d theta. Then plus 125 the integral of cosine squared theta sine theta d theta. 125 cosine squared plus 1/2 Okay. So I cannot integrate right away cosine squared, but I'll make that one as 1 plus cosine 2 theta all over 2 and d theta plus 125. So cosine squared theta sine theta d theta. And this one will become 125 all over 2. And then I'll just have d theta. So for the one, then the other one is 125 over 2 cosine 2 theta d theta. And this one is plus 125 cosine squared theta sine theta d theta. So to integrate this one, our u here is 2 theta. So du is 2 d theta. So therefore, our neutralizing factor is 1/4. And then for here, our u is cosine theta. Our du is negative sine theta d theta. Our neutralizing factor is negative 1. So that's, I'll have a 125 over 2 theta. And then, so neutralizing factor, there is just 1/2. 1/2. So 125 over 2 times 1/2 is 125 all over 4. So integral of cosine will be sine 2 theta. And then plus neutralizing factor of negative 1. So I'll have negative 125. So cosine will be cosine cube theta all over 3 and plus c. But then we don't have the 2 theta. What I have is Sine 2 theta, it's the same as 2 sine theta cosine theta. And minus 125 over 3 cosine cube theta plus c. So we have then, so 125 over 2 theta plus 125 over 2 sine theta cosine theta minus 125 over 3 cosine cube theta plus c. Then we go back. But x minus 5 is equals to 5 sine theta. So x minus 5 is equals to 5 sine theta. And divide both sides by 5. So sine theta, so which is opposite over hypotenuse x minus 5 all over 5. So writing our triangle, opposite is x minus 5, hypotenuse is 5. So this one will be 5 squared. Okay, so which is 25, then minus x minus 5 square. So which is actually 10x minus x squared. So, ano din yan? So 25. Kasi, okay. Magsusubtract din yung 25 minus 25. Okay. So we can now write our answer. So to be 125 over 2. Our theta then, so will be arc sine of x over 5 all over 5. Or x minus 5 all over 5. And then plus 125 all over 2. Our sine is x minus 5 all over 5. And then our cosine is the square root of 10x minus x squared all over 5. And minus 125 over 3. So cosine is 10x minus x squared raised to 1/2. Okay. Divide it with 5, and then raise it to 3. So finally, our answer would be 125 over 2 arc sine of x minus 5 over 5. And then plus, so 5 times 5 is 25. So 125 over 25, it's 5. So it's 5 all over 2 x minus 5 times the square root of 10x minus x squared. And minus, so 5 raised to 3, that is 525 times 5, it's 125. So 125 would just be cancelled out. I'll just have negative 1/3 of 10x minus x squared raised to 3 all over 2 plus c. And that will be the answer. So it's a bit long. So 125 over 2 arc sine, okay, and minus 1/3 raised to 3 over 2 and 5 over 2x minus 5. Okay, so it's correct. Already have a lot of examples. Okay, so that will be all. Okay, so for trigo substitution.